Hi, this is Austin with Radical STEM Tutoring, and today we're going to find out how fast the water level rises as you pour water into a cone using related rates. Let's get started. Let's look at a cone that is 15 centimeters tall with a radius of 5 centimeters. We'll pour in 3 cubic centimeters of water every second. So the rate at which the volume of water changes, or the derivative of the volume, dV dt, equals 3 cubic centimeters per second. What we want to find is the rate at which the height of the water changes, dH dt, once the water has reached 7 centimeters from the bottom. To start, let's look at the formula for the volume of a cone. Notice that as you pour water in, it forms the shape of a smaller cone at the bottom of the larger cone. The volume of this cone of water is equal to 1/3 pi r squared times h, where h is the height from the bottom that the water has reached, and r is the radius of this water cone. The derivative of this formula is our derivative dV dt, that is equal to 3 cubic centimeters per second. To find the rate at which the height changes, dH dt, we'll remove r from this equation, turning it into an equation with only v and h. Take the derivative, and then set it equal to 3. To remove r from the equation, we'll need to find r as a function of h. We can do this using similar triangles. Notice that from our cones, we can cut out a right triangle. From the larger cone, we'll get a right triangle with side lengths of 15 and 5, and from the smaller water cone, we'll get a right triangle with side lengths of h and r. Because these are similar triangles, the ratio of those two side lengths should be the same for both triangles. That is, 5 over 15 is equal to r over h. If we multiply this by h on both sides, we'll find that r equals h over 3. We can now plug this into our formula for the volume, and once we simplify it, we'll find that v equals pi over 27 times h cubed. Now we'll take the derivative with respect to t on both sides. On the left, we'll get dv dt. On the right side, we can pull out the constant pi over 27 to in front of the derivative. Then we'll have the derivative of h to the 3rd power. Using our power rule, we'll bring down the exponent of 3 and reduce the exponent by 1, giving us pi over 27 times 3h squared. And because this is implicit differentiation, we'll also get an instance of dH dt at the end. We can now set this whole thing equal to 3 and solve for dH dt. If we simplify this a little bit, we'll get that 3 equals pi over 9 times h squared dH dt. We can divide both sides by pi times h squared and multiply by 9 to get dH dt by itself. And that will come out to 27 over pi h squared. Finally, to evaluate this derivative at h equals 7 centimeters, we'll get 27 over pi times 7 squared will come out to 0.18 centimeters per second. If you found this video helpful, please be sure to like it and share it. And remember, you can book an online tutoring appointment with us right now through the link in the description. Have a radical day.